All of the different kinds of alcohol we drink are ethanol based. Ethanol, also known as ethyl alcohol, is a clear, volatile liquid that has a pungent, bitter taste. Ethanol is produced by the yeasts that ferment the sugars in fruits and grains. Tiny yeast organisms eat those sugars, and the ethanol is the waste they leave behind as they break it all down. The ethanol molecule is small and highly water-soluble, and because it's so small, when we drink it, it's very easily absorbed in our gut and distributed in the blood to virtually all the organs and tissues of our body, including the brain. Ethanol doesn't easily dissolve well into oils and fats, although fats and oils can dissolve into it. And as well as being intoxicating, ethanol is also a nutrient. But the bad news is that it's most readily converted to fat. And like most nutrients, it's most easily absorbed into our system via the small intestine. Which means that what you have in your stomach can make a very big difference to how your night could go if you're planning to drink.
When you take your first sip of, say, beer, it, of course, ends up in your stomach. What happens next depends a lot on whether you've eaten or not. If you have eaten, the alcohol is effectively trapped in your stomach while it works to break up the solid food. Alcohol can be absorbed into the bloodstream through your stomach, but this happens relatively slowly, so your blood alcohol concentration, or BAC, also goes up relatively slowly while it's trapped in there. But if you haven't eaten, well, then alcohol passes quickly into the small intestine. And here it's absorbed into your bloodstream a lot faster, mainly because the small intestine has a much larger surface area. The layer of cells that line the inside of your small intestine is called the epithelium. The epithelium is composed of several different cell types, and together they're organised into little finger-like protrusions called villi, and they're covered by even smaller protrusions called microvilli. The particular cells that absorb nutrients and alcohol are called enterocytes. The presence of villi and microvilli massively increase the surface area to help absorb water and nutrients such as amino acids, sugars, fats, and alcohol out of the small intestine and into blood vessels. Because ethanol is only a small molecule, roughly 3 times as big as a water molecule, it can easily pass through the same channels and pores that water uses to enter the bloodstream. Everything you eat or drink that's absorbed through the digestive tract into the bloodstream goes to your liver first via a special system of veins called the portal system. Within the liver, the portal veins empty into a series of small channels that act like an exchange network, and some ethanol will be metabolized or broken down on the first pass through the liver. The rest is carried with the rest of the blood to the heart, through to the lungs for oxygenation, before being taken back to the heart, and then pumped out through the arterial system to all organs in the body, including the brain, which is where the effects we generally associate with drinking happen. Ethanol acts as a depressant within the brain, meaning that it slows down the function of nerve cells. It does this by messing with the brain's neurotransmitters, which it can do because ethanol is such a small molecule that it can pass through the tight capillaries in the brain known as the blood-brain barrier. Neurotransmitters are chemical messengers used by our nervous system to communicate with nerve cells and muscles. There are a number of different types of neurotransmitters, but alcohol mainly affects 3: GABA, glutamate, and dopamine. Ethanol increases the effects of GABA, which is an inhibitory neurotransmitter, which means it decreases electrical activity in the brain, slowing it down. Ethanol also reduces the amount of glutamate in the brain, and glutamate is an excitatory neurotransmitter, so reducing its effect also slows the body down. Both of these effects are why after a number of drinks we might have difficulty speaking and poor coordination. And dopamine? Well, you would think that the onset of these effects would signal to most of us to stop drinking. So why do we often end up lining up at the bar for another drink? Ethanol increases the amount of dopamine in the brain's reward center. This increases the feeling of pleasure when we drink. The level of pleasure we derive from drinking is not the same for everyone. Some people's genetic makeup makes them feel considerably more pleasure than others. These people are at high risk of being heavy drinkers and developing alcoholism. And there is a lag between when we consume the drink and when the next level of intoxication kicks in. So you may still feel fine, or at least think you feel fine, as you ask the bartender for another round. There are also social pressures. You're probably drinking with friends or family and could be trying to impress them, or at least keep up with them, reacting to peer pressure and family or cultural expectations. So, you're feeling pleasure, your inhibitions are lowered, you're reacting to a social pressure to drink, your judgment is impaired, and your body is still 2 drinks behind your enthusiasm. Really, you have to have pretty good self-control not to have just one more drink. And you're probably not even thinking about the hangover that awaits you tomorrow morning. The effects of alcohol obviously increase the more we drink. And while it's difficult to say how many drinks equate to specific effects, there are so many factors involved, such as food intake, gender, weight, and other things. We can approximate effects based on blood alcohol concentration, or BAC. At a BAC between 0.02 to 0.03, perhaps one standard drink, there are very few obvious effects, with only a slight intensification of mood. After 2 to 2.5 drinks, in the first hour, your BAC climbs to about 0.05 to 0.06, and you might experience a feeling of warmth, relaxation, mild sedation, and you're likely to start talking more and feel less inhibited. These effects all happen in the brain's frontal lobe, which is responsible for stopping us from doing and saying socially inappropriate things. When alcohol enters the frontal lobe, it impairs our ability to control our behaviour. At a BAC of 0.07 to 0.09, your speech will start to slur and you'll not be as balanced when you move. There'll also be a decrease in reaction time and coordination, hence the legal driving limit of 0.05 in Australia. Your hearing and vision will also be impaired. And it's pretty much just downhill from here. At a BAC of 0.13 to 0.15, you'll have significant loss of coordination and balance, blurred vision, and your judgment will be severely impaired. Most people will start to feel nauseous and may start vomiting if their BAC gets to close to 0.2. At a BAC of around 0.3, you'll be in a state of near unconsciousness, if not unconscious already. Coma is possible at 0.35 and up, and death is just around the corner.